Welcome to Math, where problems are no problem. Imagine you're packing up to move and you've got one cardboard box in front of you. Two questions matter here. How much stuff can you cram inside it, and how much cardboard did it actually take to build the box in the first place? Those are two totally different questions, and today we're answering both with the exact same box. No new props, I promise. First, let's name the shape. A box like this, six flat sides, all meeting at right angles, is called a rectangular prism. Every rectangular prism has three measurements: how long it is, how wide it is, and how tall it is. We call these the length, the width, and the height. Together, its dimensions. Let's say our box is 2 feet long, 3 feet wide, and 4 feet tall. Now, question one, how much can this box actually hold? That's called volume, the amount of space inside a shape, measured in cubic units, like cubic feet. Think of cubic units as tiny 1-foot cubes you're stacking inside the box until it's completely full. To find volume for a box, you multiply the three dimensions together: length times width times height. So we take 2 feet, multiply by 3 feet, multiply by 4 feet. 2 times 3 is 6, and 6 times 4 is 24. Our box holds 24 cubic feet. Here's the plain language version, no formula. If you could fit 24 of those little 1-foot cubes inside the box with zero gaps, that's your volume. That's genuinely all volume means. How many unit cubes fit inside? Now, question two, and this is a completely different idea. How much cardboard did it take to build the box? That's surface area, the total area of every flat side or face added together, measured in square units like square feet. Picture peeling the box apart at the seams and laying it out flat. Surface area is just the area of that entire flattened sheet. A rectangular prism has 6 faces, but they come in 3 matching pairs: a top and bottom, a front and back, and 2 sides. So instead of finding 6 separate areas, we only need 3, and then double them. The 3 face types are length times width height, and width times height. For our box, length times width is 2 times 3, which is 6. Length times height is 2 times 4, which is 8. Width times height is 3 times 4, which is 12. Add those three, 6 plus 8 plus 12 is 26. Now double it, since each face has a matching partner on the opposite side. 26 times 2 is 52. So this box took 52 square feet of cardboard to build. This is exactly where people mix the two up on a test. They'll calculate volume when the question asks for surface area, or vice versa, because both involve multiplying the same 3 numbers. The trick is reading what's actually being asked. Does the question care about the space inside the box or the material covering it? Inside means volume, cubic units. Covering means surface area, square units. Same box, same 3 numbers, but 2 very different answers depending on the question. Let's double-check both answers make sense. For volume, we said 24 cubic feet. Picture the bottom layer of unit cubes. It's 2 feet by 3 feet, so 6 cubes cover the floor of the box. Stack 4 layers that tall, and 6 cubes times 4 layers gives 24 cubes total. Matches what we calculated. For surface area, we got 52 square feet from 3 pairs of faces. 6, 8, and 12 doubled. 6 plus 8 plus 12 is 26, and 26 doubled is 52. Same number we landed on before. Both answers hold up. So here's the one thing to walk away with. Volume tells you what a shape can hold using cubic units, and surface area tells you how much material wraps around it using square units. Same box, same 3 dimensions, but the question decides which formula you reach for. If this helped, the next video covers the Pythagorean theorem and how it shows up on the ASVAB. And if this channel's helping, sharing it helps more people find it too.